Alright, so today we're going to jump and do some problems from the second day of section 2.2. Again, we're reviewing algebra in preparation for doing some of the work that we need to do in this geometry class. So I'm going to jump and do a few problems on the front side here, and then on the back side there's some graphing problems that I want to get to. So the first problem here basically asks you if this point lies on a line that has this slope and this y-intercept. And so I know I can put this slope and this y-intercept into y equals mx plus b, slope-intercept form. And so y is equal to negative 3/4 times x plus 5. And then what I'll do is I'll take this x value from the 12 and plug it in for x here, and the negative 3 and plug it in for the y here. And I don't believe that those are equal to each other, so it does not lie on that line. Next problem I want to do is down towards the bottom of the worksheet. I want to determine if these points are collinear. The first thing you have to know is what collinear is. You can look it up. But basically collinear means that the 3 points are on the same line. So if I look at this and I have like 3 points, 1, 2, and like 3 here, something like that. And if I wanted to see if they are all on the same line, they all lie on the same line, I would basically be checking to see if this slope and this slope are the same. Or in other words, if I check the slope between these two and the slope between these two, and if they're the same, then I know that they would all lie on the same line. So I do the slope here. The slope I think ends up being 1/6, and the slope here is also 1/6, which tells me that yes, these points are collinear. And the last problem I want to do on the front side here is this problem number 2 at the bottom, where you're looking at the diameter of a circle which has endpoints like such as that. So I'm looking at a circle, something like this, and it's saying that the endpoints are like here and here. Do that again. 2 endpoints, and keep in mind that the diameter goes through the center of the circle, where the 2 radii are the same length. And so if I want to find the center of the circle, I would just basically go ahead and find the midpoint between those 2 endpoints. And keep in mind again, the midpoint is just the average of the x's, comma, the average of the y's. So in this case, it's going to be the average of 12, so 12 divided by 2, so it's 6. And the second one is just going to be 16 divided by 2, or 8. And that'll be the midpoint. So that'll be the center of the circle. And if I want to find the length of the diameter, all I'm going to do is plug this thing into the distance formula. Distance is equal to the x sub 2 minus x sub 1 squared, or the difference between the x's squared and plus the difference between the y's squared. Take the square root of that whole thing. When I plug this in, I know that the difference between my x values is 18, I believe, and the difference between my y values is 20. And if I simplify this, I get and plug it into my calculator, I get 26.9, and that's it for the first side. So I'm going to jump now to the back side. So we're now on the back side. We're looking at graphing problems. This first problem number 5 here, I'm looking at just graphing, basic graphing. If I look at this thing, I could put this into slope-intercept form if I wanted to. But what I'm going to do is actually use the fact that it's in a particular form, and that is point-slope form, where my point is going to be -2 from that, and positive 5 from here. So negative 2, positive 5 is right here. And then from there, I can use my slope to graph this thing. So I can go up 4 over 3. Oops, up 4 over 3 right there. Down 4 over 3, and then I can draw a line connecting them. And there's my equation, there's my line that's graphed from that equation. This problem here, again, same type of thing here. I could put this into slope-intercept form. So if I did that, I get y is equal to a half x plus 2. Basically just solving for y in this equation. And so I know that I can go up to get the y-intercept, and I go up 1 over 2, up 1 over 2, and draw my line like that. The other thing I could do here is I could actually use x and y intercepts. I know that if I want to find the x-intercept, I could set my y equal to 0, and so my x-intercept is going to be equal to negative 4, it looks like. And so it would be negative 4 comma 0 is going to be my x-intercept, which is that point right there. And then I could go ahead and, let me change the color here, make it so that my x is equal to 0 and solve for the y. And in this case, y is equal to positive 2, which we know is right here. And that's my y-intercept. And I can graph equations of lines that way. This next problem is a legit 4-level problem. It does come up pretty frequently. So if I'm going to go ahead and graph these, I have 2 parallel lines because they have the same slope. And I know that this first one here has y-intercept of 6. So I can go down 3 over 1. I can graph that. And I can do, this one has a, y-intercept of negative 1. I can do the same slope, down 3 over 1. And hopefully you can see that the 2 lines are parallel to each other. Now what I want to do here is find the distance between those 2 lines. Now what always ends up happening is students will just give me this distance. They'll just say, hey, the difference between the y-intercepts is just 7, so the distance must be equal to 7. And the problem with that is not how we measure the distance between 2 things. If I were in a room, and this is a top view, and I was sitting here, and I said, how far am I from this particular wall right here? I would not give you the distance from here to this part of the wall. I would give you the perpendicular distance, or the closest distance to that wall. And the same thing is true here. I'm looking for the perpendicular distance, or the shortest distance between these two lines. And so the easiest way to do this is to basically pick a point that is convenient. And I'm going to pick this point right here because I already know what that point is. It's 0, 6. And I'm going to find this distance from here to here. Now, the nice thing here is I already know the equation of this line, and I can pretty easily find the equation of this line if it's the perpendicular line between these 2 lines here. So the perpendicular line here is going to have a slope that's perpendicular to those 2 lines, which is the opposite reciprocal, so the slope's going to be positive 1/3. And I know that this point right here is a point that's on that green line. So I can plug this into point-slope form, or actually slope-intercept form, since I know that this is the y-intercept. So it's just going to be y equals 1/3, that's my slope, x, plus 6. That's the equation of the green line. And I know that the purple line, which is this one right here, I already know the equation of this one, was y equals negative 3x minus 1. And if I can find this point right here, this intersection point right here, then I can just take this point and these 2 points here, and I can find the distance between those 2 points using the distance formula. So to find the intersection, I just solve this system. Good old, I don't know what chapter it is for many of you, but I know that the old algebra book we used to use, it was chapter 8. So I can use, solve this thing, just use substitution method, 1/3 x plus 6 equals negative 3x minus 1, solve for x. X ends up being something kind of crazy, like negative 21/10, I believe. And if I plug this back in, my y ends up being 5.3. That is this point right there. Once I find that point, I already know this point over here, plug it into the distance formula. Okay, so this point as well as 0.6. And if I plug it into the distance formula and use my calculator, I will get 2.21 as my answer. Okay, you might want to watch this, rewind this video and watch that problem again. It's a problem that pops up throughout the book, whether it's on the final or on the end of the chapter test. It just is something that pops up periodically throughout this book. All right, I'm going to go ahead and stop here and give you a chance to try some problems. All right, take care.